I find it very helpful when you're dealing with X and Y coordinate points to make a graph. Like if it's asking you stuff about the graph but it's not showing you the graph, don't play that game, just draw the graph. So what I have here is a bunch of statements about this mysterious polynomial function, f of x. We don't know what kind of equation that is, but we do know that f of 2 is 0, which means, if you think about it, that means f of x equals 2 equals a y value of 0. So that's 2 comma 0. That's my coordinate point. And what I've done is I've turned each of these statements into a coordinate pair and then graphed it on this chart right here, on this xy diagram. But we sure don't know what kind of a shape fills in the picture, do we? All we know is that it's polynomial. Well, that actually tells us quite a bit, because polynomials have two characteristics that are very important. They're continuous. That means there's no gaps, like asymptotes or holes. There's none of that stuff. And they're smooth. So there's no corners, there's no pointy stuff. They're all just continuous, smooth, curvy things. So that's wonderful, because that lets us draw pictures like this silly thing that I'm drawing right here. Maybe this is the curve. Who knows? Okay, that could be it. Or it could be something different. So we're going to have some kind of a connection here between these points. And now let's see, what am I looking for? I want guaranteed extrema. Those are minimums and maximums. So let's try to draw the simplest curve possible and not make it so crazy. We could draw something like this. Okay, see what I drew there? That's not bad. Maybe that's the polynomial. Who knows? If it is, where's the maximum? You can get a hint here by looking at the highest point on the graph and saying, well, maybe this is the maximum right here at -1, 8. Could be. I drew a little bit of a hump to the left, so maybe it truly does go higher there, and maybe the maximum is over here at like negative, I don't know, -4 in x? We don't know. Or maybe the maximum is way skewed to the left. Like maybe this thing goes up really steep and then comes back down, and the maximum is at -7.9. Could be. We don't know. But we do know that it must be somewhere in between these points, -8 and 0. The maximum's got to be in there somewhere, because the polynomial must have room to reach the coordinate point in the middle, the -1, 8. So in between those is one of the extrema. So if I wanted to put that for my answer, that would be fine. I could say in between -8 and 0. There's a guaranteed extrema in there. But likewise, if you wanted, you could argue and say, well, wait a minute, doesn't there have to be a minimum value in between the -1, 8 and the 2, 0 coordinate points? Right? It must go lower somewhere in there. So between those, there has to be a minimum. And you could also very easily argue that the guaranteed extrema is between -1 and 2, right? If you're talking about the minimum, it just depends whether you're talking about the max or the min. So you have multiple correct answers for the way this problem works out just because of the orientation of those dots. But if my dots had been in a different arrangement, then you might have been a little more restricted in those answers that you give. Okay, so you really just have to draw the graph and reason your way through it in terms of mins and maxes.